That's a weird compound for our discussion here. Noradrenaline. The compound is noradrenaline. Discussion is based on this noradrenaline. The compound has several functional groups. What are the functional groups available here? What sort of functional groups are available here? First, let me write them down. We have secondary alcohol. I have written this secondary alcohol word just after the functional area of the molecule. And this one is amine. If I write precisely, I can call it primary amine. Primary amine. And these two are phenol functional groups. Phenol groups. Give the molecular formula of noradrenaline. The compound has carbon, hydrogen, oxygen, nitrogen. How many carbon atoms are there? We have 6 carbons in the ring. 6, 7, 8. How many hydrogen are there? We have, in the ring, there are only 4 hydrogen. Why? There's 1 hydrogen here, 1 hydrogen here, 1 hydrogen here. In other places, there are substitute groups. So 1, 2, 3, 4, 5, 6, 7, 8. Plus, there's 1 hydrogen. And there are 2 hydrogen here. Now let us count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hydrogen 11. Oxygen 1, 2, 3. Nitrogen only 1. I think this is right. NC8H11. All right, we go to the next one. In the next one, we have state whether or not noradrenaline shows stereoisomerism. Stereoisomerism. What is stereoisomerism? Stereoisomerism comes in 2 ways. What are the stereoisomer types? There are 2 stereoisomer types. First one is geometrical isomers. Geometrical. Second one is optical. Geometrical isomers come as, I'll write cis trans. It's easy for us. We don't talk about easy isomers, cis trans. And for optical activity, there are 2 stereoisomers. One we can say D molecule and L molecule. We see plus and minus also. This basic thing should be understood. Geometrical isomers give cis and trans. Optical isomers have D and L. This D and L, we don't learn about in our syllabus. If we can draw 2 optical isomers as mirror images, that is the maximum thing you are expected to know. For geometrical isomers, we have cis and trans. In cis molecules, there is a carbon-carbon double bond. On either side, you can have similar, let's say this is R1. Here we can have R2. Here probably we can have just outright H. This is a trans molecule because the hydrogen, they appear, similar groups on each carbon atom, they appear far away from each other across the double bond. And if this is a trans, what is the cis type of molecule? Cis, I can do carbon, hydrogen R2, double bond, carbon H. Here we have R1. So this is a cis molecule because similar groups are appearing closer together. All right. With this knowledge, I think we can handle this question. State whether or not noradrenaline shows stereoisomerism. Okay, we'll see. Definitely, this cannot show cis-trans isomerism, so geometrical isomerism, because there are no double bonds to be seen in this area. But I can see chiral center. What is the chiral center? Chiral center is a carbon atom which has 4 different groups or 4 different groups of atoms attached to. So this is a chiral carbon. Because of the presence of chiral carbon, we can say this shows optical isomerism. What type of isomerism shown by this? It shows optical isomerism. Because it contains chiral center. We can write within bracket for you to learn also. A carbon atom which is bonded to 4 different atoms four different groups of atoms. We go to the next question. HNO2 is added at 5 degrees Celsius with separate samples of noradrenaline and phenylamine. The reaction with phenylamine produces a stable diazonium ion. The reaction with noradrenaline produces an unstable diazonium ion. Suggest why the diazonium ion produced with phenylamine is stable. Let me go through the question again to find out the reagents used. HNO2. This is not HNO3. It is HNO2. HNO2 is nitrous acid. Why do you think we use nitrous acid in this? This lesson is done in phenol lesson. Of course, it is touched in benzene as well. This is phenylamine, NH2. We can convert this NH2 to something called phenyl diazonium ion. In phenyl diazonium ion, there are 2 nitrogen atoms bonded through a triple bond. The middle nitrogen is having a positive charge. But if you use something like CH3, CH2, NH2, we can convert this also to a diazonium ion where we have CH3, CH2, NH2 goes out and comes in triple bond N plus. For both these reactions, we have to use, the question says HNO2. HNO2, HNO2, yeah, not HNO3. And then temperature. Temperature matters very much. Temperature should be between 0 to 10 degrees Celsius. However, this HNO2 is prepared in the system itself by reacting sodium nitrite and HCl. When sodium nitrite and HCl are reacted together, we get HNO2. And this HNO2 nitrous acid is stable at 0 to 10 degrees Celsius. So HNO2 is able to change its phenylamine into phenyl diazonium ion. If you give the same condition, we can make a similar compound with a normal alkyl amine also. But the question says the structure given by not hydrazine. This is phenylamine. The product given by phenylamine, this is called phenyl diazonium, and this is more stable. And this is less stable. Only thing is this. In this, there are double bonds. N plus triple bond N. The positive charge in this molecule can distribute in the ring. Remember it like that. If you have a positive charge of an atom attached to a benzene ring, this positive charge can spread across the benzene ring and produce a stable compound. But here, this positive charge cannot spread to the left-hand side of it because there are no delocalized electron systems. Here we have delocalized electron system. Next to delocalized electron system, we have a nitrogen with a positive charge. Through electron delocalization, this positive charge can spread everywhere in the molecule. If a charge separation in a molecule is going to distribute, we call it delocalized, then that structure is going to be stable. Because such distribution of positive charge is not available in the second compound I have taken into consideration, it is going to make a less stable structure. Now, question is telling HNO2 is reacted with at 5 degrees Celsius with separate samples of noradrenaline and phenylamine. Noradrenaline. In noradrenaline, shall I show the structure? What happens is this goes out. And that part changes to N2 plus. Over here we have CH2. This positive charge cannot distribute in the aryl ring because it is not directly attached to the aryl ring. But if you take phenyl diazonium ion, NH2 plus, N2 plus, I'm sorry, N2 plus, this positive charge can distribute in the benzene ring and make a stable structure. You will write that. So here's why the diazonium ion produced with phenylamine is stable. The positive charge on the diazonium ion. Diazonium ion means NH2, N2 part, N2 plus. The positive charge on the diazonium ion can delocalize, in the aryl ring through, we can write through resonation. The ion is more stable when the positive charge gets distributed or delocalized? Let's start this work again. The noradrenaline molecule reacts with HNO2 molecule, nitrous acid. The products are one water molecule. So I wrote water molecule here. One molecule of an unreactive gas. If you think about these elements, carbon, hydrogen, oxygen, nitrogen. What should be the unreactive gas? I think unreactive gas is N2. Now nitrogen N2 goes out, H2O goes out, and some compound comes over here. I can think like this. How do you get, no, this compound has only one hydrogen. But how do you get N2? Maybe this nitrogen is also coming into it. One nitrogen here, one nitrogen here, they go out as N2. And one water molecule has gone out. Now we have to figure out from where the water molecule goes out. Definitely, this big group doesn't change because it is not in the functional area. So we write OH here, OH here, OH here, CH2, OH there, and 2H2. We'll go to the next question now.